This data set includes information about 40 individuals, their gender, age, how long their foot is, how long their shoe print is, their shoe size, and their height. All length measurements are done in centimeters, which is why they may look a little funny to you. I'm going to choose two variables from this data set I think are related. I think your height and your foot length are related. The longer your foot is, the taller you should be, right? That would mean it's a positive relationship, as both of these would move in the same direction. Increase in foot length would be an increase in height. And I'm going to judge this at about a moderate strength level. I do think there's a definite relationship. However, I do know several people who are very close to me in height personally who have smaller or larger feet. So I'm going to judge it at about a moderate. In this case, I am going to use foot length to predict height, making foot length my x variable and height my y. Let's see what the numbers have to say. Under the Data tab, choosing the Data Analysis tool pack, I will find a regression tool right in alphabetical order. Once I have this tool open, I can choose the x and the y variables. So I want to be careful though. Most of us are very used to x coming first and y coming second, and in this tool, y comes first. So you want to be careful. Remember, I was going to use foot length as x to predict height as y. So under the y, I will highlight all my y variables. Let's put that in the actual y column. Under y, I will highlight all of my y variables. Under x, I will highlight my foot length variables. Noticing I am highlighting the labels. I just like to keep things organized with labels, so I will click the labels button and hit OK. The following output is presented, and this output has a lot of great information on it. First off, it contains my r-squared value, which tells me how strong the relationship is. It is 0.71 approximately, which is about a nice moderate relationship. It's not super strong, but it's also not weak. I will notice if you want to find the r value, you can by taking the square root, SQRT, of that value. So if you want to find the correlation coefficient or the r value, there it is. Now, the slope or the value right here with foot length is positive, which does confirm that this is a positive relationship. So my r value remains positive. If the slope had been negative, it would confirm a negative value, and you would have to manually make your r value negative. I also can write an equation based on this output. Y equals the intercept, and I'm going to carry 2 decimal places, plus the slope attached to an x. That means I can predict your height based on your foot length. So if you come to me and you say that my foot length is 29.8 centimeters, I can fill that in the equation and use that to make a prediction. Taking a calculator out, I'm going to notice that 4.29 times 29.8, and you do want to use a calculator when you're working with decimals, times 29.8 is 34.09. That means I would predict, when I add the 64.13, that you are 98 inches tall. Or not, excuse me, not inches, that would be very tall, 98 centimeters tall. There we go. Keeping in mind that that's just a prediction, it's not an absolute, but it does give you kind of a general ballpark. The regression output does contain a lot of great information, including more stuff than we talk about within the scope of this class, but it's a great way to get a handle on your r-squared, your r value, and your equation for the line of best fit.